Hello and welcome to this ARA webinar with staff from the Council of Producers and Distributors of Agrochemicals titled Adjuvant Advantage for the Sales Agronomist. The goal of this webinar is to address how to effectively use adjuvant tank cleaners as a way to reduce cross-contamination problems from spray application equipment and is sponsored by Copcoat Farm and Forest Protection. Thank you, Copcoat, for sponsoring today's webinar. My name is Hunter Carpenter, Senior Director of Public Policy with Agricultural Retailers Association, and I'll introduce our webinar speaker in just a bit, but first I'll go over a few things so you know what to expect. First, thank you for taking the time to be with us today. Webinars are an important part of the ARA professional development pathway and provide a great opportunity for ARA member companies to help educate their employees. Questions will be addressed at the end of the presentation, but you can type them into the chat panel of the Q&A function at any time during the presentation. Today's webinar will be recorded, and the recording will be made available to all member companies under the member-only section of the ARA website. As a reminder, you can log into the member-only dashboard to access past webinar recordings, and if you do not have an ARA login, you can email info@aradc.org to set one up. You will also be able to scan a QR code at the conclusion of the webinar and receive one IPM CEU credit for your Certified Crop Advisor certification. So with that out of the way, I'm excited to introduce our speaker, Johnny Roberts, Director of Education for Adjuvant Chemistry at CPDA. Johnny has 45 years of experience in the development and technical support of pesticide, fertilizer, and adjuvant formulation. 44 of those years were spent with Helena Agri Enterprises. Johnny is also the co-inventor of 15 U.S. patents related to pesticide, adjuvant, and nutritional formulations. We would also like to add a special thanks to Jim Reese, VP of Product Development with Precision Laboratories, for assisting as a technical advisor for today's webinar. We'd also like to acknowledge the CPDA Advisory Working Group for their work in putting together this series of webinars. I will now turn it over to Johnny for some background on why today's webinar is so important and why CPDA has chosen today's topic. Johnny?
Thank you, Hunter. Before we start our webinar, I thought we'd give a little bit of an overview of a project that we're working on here at CPDA. As many of you know, there's been some court-ordered action around the Endangered Species Act, and registrants are going to have to implement means of reducing that potential impact. And what it involves primarily is with buffer zones. And so our direction is to create a case and build a case of demonstrating how adjuvants have a role in mitigating these buffer zones. Next slide, please. So these tools, the agency's working on several of them. If we don't get some type of mitigation tools approved, then we're looking at the potential removal of a lot of arable land. So these mitigation tools are a big part of that strategy to reduce these buffer zones. CPDA is working to come up with a mechanism for ensuring that adjuvants are considered for this mitigation approach, and also for a method and a way of qualifying them for that use once they are approved. Next slide, please. We know how to do these things. So we've had a history of building sort of industry self-regulatory systems. The example that most people are familiar with is with the CPDA Adjuvant Certification Program. So we will be working on a program that will satisfy the agency's concern that if adjuvants are indeed approved as a mitigation tool, that we have a way to measure and assure that is the case when they are recommended for reducing buffer zone sizes. Next slide, please. So back to our webinar and what we're going to focus on. And as we've talked about in all of our presentation, the adjuvants as a group they're quite extensive, the number of different products and types that are in them. You can essentially divide them into two categories: those that are enhancers like non-onyx surfactants, crop oil concentrates, methylated seed oil, And then those that are utilities, materials that don't really have a direct impact on pesticide efficacy, but they do impact the application. Things like compatibility agents, foam control products, deposition aids, and water conditioners. Today, we're going to focus on tank cleaners. Next slide, please. So what are some of the resources? Fortunately, this subject is a very important one. It's been studied extensively in the past 10 years. You will find a number of references available. The three that I'll be leveraging off today is one publication put out by Purdue Extension, and this one called Removing Herbicide Residues from Agricultural Application Equipment is very useful. It concentrates not only on the tank cleaners, but also on the technique. Same for the decontamination fact sheet published by the Grains Research and Development Corporation Australia. Another good reference dealing with both technique and the tank cleaners themselves. Next slide, please. So what we are looking to accomplish with today's webinar, and as far as our agenda, what are the resources for tank clean out procedures and products? We've covered those. I think they're quite extensive. What are the types of tank clean out products that are in the marketplace today? And what are the general guidelines that we use for in using these materials, how to use them correctly, and then getting into a little bit of the specifics on tank cleaners with specific herbicides that impact which ones you use and how effective they are. And importantly, the last item will be on some safety guidelines that we need to follow when using tank cleaners. Next slide, please. So, what are the general guidelines that we follow for minimizing spray equipment contamination? Well, one of the big rules is we clean out our application equipment as soon as possible. The longer it sits in a state of not being cleaned out, your problem becomes that much more difficult to manage. We know that stainless steel retains less residue than that of synthetics. We know that if the pesticide is water soluble, it's by far the easiest to remove. We've also know that with dry products, if we don't fully disperse them in water, they become a problematic themselves. We know that if the spray mixture contains an oil or emulsifiable concentrate, we have to double up on our efforts to clean them out. But the real point of this webinar today is that we're going to focus more on the tank cleaner products and not the technique. The techniques are quite involved. They go from everywhere from cleaning out spray caps and booms to specific recirculation procedures. Those are too complex for this webinar today. We are strictly going to focus on the tank cleaners themselves. Next slide, please. So what are the types of tank cleanout materials that are out there? And there's quite a range of them. Some of them are just simple detergents and soaps. Some as basic as just dishwashing liquids. Others are what we call solubilizers. There are two of them. There's an alkalinity solubilizer and there's an acidity solubilizer. And these materials work by making the pesticide residue more soluble in water so it's more easily flushed. They also have, particularly in the case of alkalinity solubilizers, the ability, depending on the pesticide active, of actually decomposing it, rendering it less harmful, and actually removing it from the system completely by that method. On the alkalinity solubilizers, we have ammonia, caustic soda, potassium carbonate. On the acidity solubilizers, they tend to be a lot less common. Examples would be phosphoric and muriatic acid. Another group are the oxidizers. Examples of them are things like bleach, peroxides, hypochlorites. The intent of these materials is not to necessarily solubilize residue, but to actually decompose them. And then you have a whole range of combinations. You'll have everything from tracer dyes to foam control agents. to even co-organic solvents mixed in with the tank cleaner to better facilitate residue removal. Next slide, please. So by any measure, by far, most of the tank cleaners that are out there that are being used are what we call homemade ones. And this has been the case for many, many years. We simply would use household detergents and soaps. Um, Household ammonia was extensively recommended and used. And these materials were working for us to a pretty good degree back in the early years, but the pesticides that we deal with today have really moved past their ability to be addressed with these homemade cleaners. We've talked about how household ammonia is often used. The problem with that one, it varies in strength. It can be anywhere from 3% to as low as 1%. Oftentimes, this is not alkaline enough to be effective in solubilizing residues. Ammonia and caustics that are often used as tank cleaners lack surfactant and other components that disperse and flush out water insoluble residues. And so what you find is that with many of these homemade tank cleaners to be effective, it often takes additional rinse cycles and longer soak times to get them to work effectively. Next slide, please. So what are some of the characteristics? You know, if you're looking at a particular spray mix to clean, what are some generalizations that you can use to know if you're going to have an easy go at it or a difficult one? Well, if you have a dry formulation in spray mix, and these are quite common, WDGs, wettable powders, these materials can be difficult to remove from systems, particularly if they've not been fully dispersed in water and or you've had some kind of incompatibility that has kept them from dispersing. As you can imagine, dry, undispersed materials get trapped into the hoses and crevices and spaces that are all throughout the equipment. So they become a challenge to remove. If the particular pesticide active is insoluble in water or the fertilizer that you're using, then they're not as susceptible to rinse cycles. It can take more than what we typically follow to remove them because they are not flushing out with the water rinses, and they too can hide, get into places where the water cannot reach. And then we've had the advent of particularly very low dose pesticides, sulfonylureas, auxin herbicides like dicamba and 2,4-D. These materials can cause issues at extremely low concentrations. And so you're getting into levels of residue that are extremely tiny and not really visually present and still be able to cause some injury. So those are some that we have to take particular concern with. There are still emulsifiable concentrates in the marketplace. These are solvent based. They oftentimes can be difficult to disperse once the residue has been removed or sprayed out of the tank. They have a tendency to cling on to the sides of equipment, particularly if it's synthetic, and they too can cling and particularly into hoses and be problematic to remove. And then if we have an oil-based adjuvant like a crop oil concentrate or methylated seed oil, and we have those present in the spray mix, and they happen to be of poor or questionable quality, if their emulsions break, then they too will make various deposits and residues and films that are difficult to remove. Next slide, please. In this little demonstration here, you can see the impact of alkalinity on a sulfonylurea herbicide. Uh, when you look at the water alone, you can visually see this particular herbicide mixture with your eyes. It's not dissolved. It's kind of a murky, turbid appearance. And then if we add a alkaline-based tank cleaner, then it's almost like magic. It disappears. It becomes very water soluble and hence easy to flush out of the system. And so this is sometimes confused with thinking that it's decomposing the herbicide. Not necessarily. It's just simply making it more soluble in water so that it responds more readily to water rinses. Next slide, please. In this experiment here, we show the impact of spray mixes that contain emulsifiable concentrates or oil-based adjuvants. And you can see in the uh, 4 containers above, there is an oily residue that is making the residue cling to the surface. There's a tendency for this to go all through the system, and it's the oil itself creating a film that is able to attach to the surface, particularly synthetics, and that in turn retain the pesticide residues that are insoluble in water. So an effective tank cleaner is one that has a component that can disperse this residue to make it more susceptible to the flushings. And so the same spray mix, you look at the pictures below. If we use ammonia only, we've had some impact, but you can still see the appearance of residue being left behind. Whereas with the tank cleaner that contains a surfactant component or co-solvent, that residue is removed. So that shows you how critical it is. We're going beyond just the issue of making things more soluble. We also have to disperse, flush out any kind of residues of oil that are left behind. And be aware that not all pesticides are subject to neutralization by a tank cleaner. And so we're often relying on other components to not only solubilize, but neutralize the residues that are left behind. Next slide, please. We've had with the popularity and the advent of water dispersible granules and wettable powder type pesticides, we have an issue here where if we don't get that material fully dispersed in water, then we'll have solid residues hiding in various parts of the application equipment. Uh, Not only is this a clean out issue, but as we have discussed in previous seminars, it's a compatibility one. So it's very, very critical that we get our water-based materials, solid-based materials dispersed fully in water before we start the application. And then we also worry about the residues left behind. As you can see in the slide, the picture above, the residue that before we flush out with the system is quite tenacious. It sticks to the sides. If material is fully dispersed with the tank cleaner, it cleans out well. And again, just to reinforce what we're trying to do with these tank cleaners, at the end of the day, it's the water that's doing all the heavy lifting. It's the triple rinses that we follow. Our goal is to put these residues into a form where the water more readily can remove them. Another thing to stress is this issue of oil-based adjuvants not emulsifying properly. That will make this particular problem worse. It again provides a film for the residue to stay behind in, making it more of a challenge for you to disperse. But the whole goal here is, I wanted to reiterate, is to get this residue into a form that we can flush out in water itself. Next slide, please. This summarizes a really interesting study that was done a few years back by a group of researchers out of Mississippi State University. And this is a peer-reviewed paper that's published in Weed Science back in that period of time. And what they were studying was how the hose materials can impact the trapping of residues. And it's common knowledge that rubber hoses in particular are a problem with decontamination. So they wanted to study and learn why. And they did some interesting electron micrograph studies on the surfaces of various hoses that have been exposed to pesticide sprays. And they found that the issue with rubber is that There's lots of cracks, crevices, small holes throughout the system. That's what is trapping the residues. And as you could imagine, it's even more of a problem if there's an oil-based material running through it. It can literally act as like a shield or a film over those residues, preventing them from being fully dispersed with water. And if you look though in those same systems through a um, polyethylene type hole, synthetic, there's very little areas for it to be trapped and impinged, so they're much easier to decontaminate. Now, what this has in relationship to how we use tank cleaners, if you had to rank them, rubber by far is the worst, PVC is somewhere in between, and polyethylene is the best. And if we are having to manage a spray system that has rubber, be aware that longer soak time should be applied and the number of rinse cycles increased. And you'll find that in a lot of these applications now that people are even going to the point, particularly with some of the custom applicators, of just changing out the hoses. It is possible to decontaminate rubber hoses, but just be aware that you're going to have to take more effort and likely more cycles to make that possible. Next slide, please. So what are some of the general guidelines for using all tank cleaners? And what you'll find, some pesticide labels, not all, but some will have very specific recommendations for the type of tank cleaner to be used. They're sometimes quite generic and not clear, but they're getting better. And there are references oftentimes into the strength of the ammonia that you'd have and those type of things. But it is getting better with some of the specific recommendations that you need to follow. Another thing to be aware of is that, and this has happened unfortunately in the marketplace, they don't. There's no magical tank cleaner that eliminates the need for proper spray equipment, technique, or procedures. There's just not one out there. You're still going to have to follow those. You're still going to have to follow the number of rinse cycles that's recommended or suggested. So there's no magical product to make that job easier. The goal here is to make the job better and more um, uh, useful for what you're trying to achieve. Another thing to be aware of, that some of these tank cleaners, particularly the ones that are based on peroxide and hypochlorites, may have an expiration date. Make sure that these materials have not gone past their expiration dates. Sometimes they tend to hang around a bit longer than other products in the warehouse, and so they can run past their expiration date. So make sure that is not the case. Another thing to anticipate, the downside of the tank cleaners that have the detergents and surfactants in them is that they're going to foam. So you could expect a foam generation problem going through these tank clean out procedures. And for there, we have the tools of our foam control agents, which, as we learned in previous seminars, work best when used first. So keep those in mind, and you'll also find, besides removing the nuisance of the foam, you'll just get a better overall cleaning of the system if you don't have a lot of entrapped air in the form of foam. And then another thing we'll stress that, and this is the case with many pesticides, you may lack specific tank cleaner directions. And in a case like that, we always defer to the manufacturer. Oftentimes they have tank bulletins, they have other recommendations outside of the label. So if you have questions in that area, that manufacturer should be able to help you with those. Next slide, please. So what are some of the specific herbicide use guidelines that we have to manage? We have some that have kind of a particular direction or guideline for using them. The sulfonylureas, which we mentioned earlier, there's all sorts of examples of them: difensulfuron, tribenzuron, those type of materials. The general direction that they've had in the past is just making those residues more soluble. And that is achieved by raising the pH. And you'll find that the tank cleaners that are based on ammonia and caustic are typically sufficient to do that. But be aware that if that spray mix is acidic, and that's very common, we use water conditioners, we use any number of things to make acidic spray mixes, or if there's an oil combined in that spray mix, then your clean out efforts become more of a challenge. If it's acidic, the sulfonylurea tends to not dissolve in the water and becomes difficult to flush. And if it's oil, as we've talked about, it can create a residue that retains the material behind. So for these particular herbicides, follow the guidelines of looking for something, a tank cleaner that gets the pH up, but at the same time has a surfactant or co-solvent component that helps flushing out any of the oil-based residue. Now, when we get to the auxin herbicides, 2,4-D, dicamba, MCPA, these materials, and of course, they have long been a very problematic herbicide residue to remove because of their potency of being able to cause damage at very, very low levels. We have two auxin herbicide formulations in the marketplace. The most common by far are the salts, things like 2,4-diamine, things like DGA, dicamba, those type of things, the Banville salts of dicamba. These materials are water soluble on their own. So unless you have a really acidic tank mix, they will readily flush out in your water rinses. However, it's important to keep the pH on the alkaline side. And so again, using your alkaline-based materials, tank cleaners, they keep that on the basic side, alkaline side, so that they readily flush. Now, another group, another formulation type that's quite a bit different is your ester forms of 2,4-D. We don't have any of the dicamba, but we do have them with 2,4-D. We do have them with triclopyr and some others. These materials are oil/solvent based. And as we learned earlier, those are by far the most difficult to remove. They tend to cling to the surfaces of the application equipment, particularly if it's not stainless. And so in those cases, they're not soluble in water. So you need not only the alkalinity from the tank cleaner, but some type of surfactant in with it as well to help lift those residues and remove them. Auxin herbicide esters are extremely problematic, for example, with rubber hoses. You have to go to the extent of even using diesel to remove some of the residues from esters in that particular case. So of the two, be aware that the esters are always the one to watch for and to manage the most. Both are very important. Both are very problematic, but the esters by far are the most difficult. And we get to another problematic material. It's flumoxazin or Valor. And this material is one of the newer herbicide types that had its own issues with cross-contamination in tanks. And the goal there is to increase its water solubility. And it takes a fairly high pH to do that. You have to get above 12. You'll find some specialized tank cleaners just for flumioxazin products. You'll find directions. The best tank cleaners for this one are the ones that really get the pH up high and get that residue soluble so that it can be susceptible to the water rinses that you're doing. Next slide, please. So wanted to wrap it up here with some of the safety guidelines that we have to follow with tank cleaners. This has become even more of an issue in I'd say the past 5 or 6 years as we have more highly caustic materials being used as tank cleaners. And again, this is the direction that we're going to. We have to use these materials to get some of these residues soluble in water. And many of them can be very injurious to eyes and skin. So strictly follow your personal protective equipment guidelines that will be on the labels. It's critical that you don't take any shortcuts around that you follow all the guidelines that give. Another thing we need to stress is, and it's one of these homemade recipes, and also one that is sometimes encountered accidentally, and that is we never mix ammonia with chlorine slash hypochlorite bleach products. If you do that, and part of the reasoning behind that is that, okay, I'm going to use the ammonia to get solubility of the residue, and I'm going to use the bleach to neutralize the residue. The danger in that, and when you put those two together, you can generate some extremely irritating and actually toxic fumes that can be very detrimental, particularly in closed spaces. So we do not mix those two together under any situation. Also, if you've just got a bleach-based product and your spray equipment had an ammonium fertilizer in it, was the last thing through it, and then you introduce this bleach, you run the same risk. We don't do that. We avoid that. So the bottom line is that we keep bleach away from ammonia. Also, you'll find some carbonate-based products, tank cleaners that are in the marketplace. These materials will violently FRS. They essentially act like Alka-Seltzer on steroids if they come in contact with undiluted acids, or even in many cases a diluted acid. And this effervescence can be an issue with buildup of pressure or just exposing workers to a residue that is flashing out of the system. Also, you'll find peroxide-based products in the marketplace, as we discussed. These materials are oxidizers, and they're going to have their own special storage and mixing guidelines on how to safely use and store them. Critical that you follow those. They're very different in their safety and handling aspects and compatibility as well. Next slide, please. So, customer objections. And this is an exercise that we do with all of our webinars, and that is, okay, I'm trying to convince a customer, an applicator, that they need to use a tank cleaner. What are their objections, and what would our rebuttal be? And you'll often run into this. Triple rinsing should be enough. The label says only to triple rinse with water. But the problem here, as we discussed, is that many pesticides are not soluble in water, and so they do not readily flush out with it, regardless of the number of cycles that you do. So yes, a triple rinse of water would be effective if the material was fully water soluble, possibly, but you don't know when that's the case, and it's difficult to manage that. And many things will fall out of that solubility depending on what else is mixed with them. So another objection you might find is, well, I'm just going to use a household cleaner. That's what I've been using before. I'm going to use ammonia. I'm going to use lye, those type of materials. And as we have learned that most of these household cleaners are just detergents, they do not impact residue or water solubility. The ammonia-based materials would, but you do not know how strong they are. They don't meet any kind of a guarantee or performance standard for doing what we're trying to do, and that is solubilize pesticide residues. So this goes back to the second one is, well, why not just use ammonia? And again, we've talked about the weaknesses of not knowing the strength and of not having anything in that ammonia to solubilize it. And of course, we are always sensitive to the cost of inputs, and this is just an extra expense. This is an extra cost. But we would argue that minimizing the risk of cross contamination cost less than the problems of not preventing them. And we know that cross-contamination is a big issue with pesticide sprays. Oftentimes, what someone assumes is a drift issue or a volatility issue is oftentimes a cross-contamination one. So it's very much worth the extra attention and training to manage and use these type of products correctly. Next slide, please. So to kind of summarize, what does all this mean? So when should you use them? Well, you're going to have some guidance in that from the pesticide label, tech bulletins. You'll find some university extension publication that will guide you on when and how to use specific tank cleaners. Some of the other guidelines that you should follow is that you match the cleaner recommendation with what the label is directing you to do. If you have some reason to deviate from that, then of course, always go back with the manufacturer. And again, to stress how these clean outs, it's not unlike dirty dishes at home. Clean them as fast as is practical to do so. Decontamination processes work much better when they're done as soon as we're able to. Another thing of note here is that we know that the longer that we allow equipment to soak in the rinse or tank cleaner solution, the better they work. As a rule of thumb, we like to say 12 hours for this soaking process, but we may extend that if we've got rubber hoses and things of that nature that we're trying to clean. So again, the longer the solution is allowed to stay in contact with the equipment, the better its chance to do its job. Next slide, please. So we want to thank everyone for their attention. Hopefully it's been useful to you. It can be a subject with some complexity to it, but it's getting better. And glad to say that we have a lot of tools at our disposal to make that job easier.
Thanks so much, Johnny. Great presentation. We're going to start with some Q&A. First, I want to remind everyone that you can scan the QR code that's on your screen. Follow these easy steps to make sure that you get your CEU credit. So I'll read off some of these questions and leave this up for a little bit. So Johnny, first question. 2,4-D, like Enlist, they're more closely like amines for Cleanout, correct? This is versus an ester formulation.
Correct. They are amine based.
The second question, are all tank cleaners safe to go spray over the crop of the with the pesticide being cleaned out of the tank?
Yes, I'm not aware of any crop injury issues ever coming from a tank cleaner solution. If they're used at the proper rate, I can't envision them causing an issue like that.
Okay, I don't see any other questions coming in. I do want to remind everyone of the next webinar. We've had to change the date on this, so it is now February 22nd at 1 p.m. Eastern. We will have a webinar on adjuvants and aerial application, sponsored by Brant. So thank you, Brant, for your sponsorship there. But I will leave the QR code up. And I'll stay on. Johnny will stay on with me for the next 5 minutes or so. If anybody has any questions, if you don't have questions, feel free to jump off the webinar. But we will keep the line open for anybody that might want to scan this QR code or ask a question. And we will shut it down here in about 5 minutes. So thank you again to everyone for joining today. Thank you to Copcoat for sponsoring, and thank you to the CPDA Advisory Working Group for their help. And Johnny, thanks a lot. You were great.
Thank you. I enjoyed the webinar.